All right, see Lindelof videos, AP Cal, implicit trig. In this case, we're not only asked to differentiate implicitly, but we're also asked to evaluate the derivative. So we're given this. We're given that tan of x plus y is equal to x at 0, 0. You can test this to see that it's true. Tan of 0 is equal to 0 is actually true, so I'm going to go ahead and proceed. First thing I'm going to do, I'm going to pursue this as if this is a multiple choice problem, because I think that's where you're most likely to see it. So I'm going to show you my scratch work. This is what I'm doing. I'm going to take ddx of this whole thing. So I'm going to take ddx of tan of x plus 1 set equal to the derivative of x, right? I'm keeping in mind this 0.00, but I'm not going to do anything with it yet. I'm going to do this easy differentiation first. The first derivative of x with respect to the first derivative here is just 1, isn't it? So there's this 1. I'm just taking this derivative, so I did that. And now I'm going to start to differentiate here. And what I want you to notice is that what we have here is we have a chain rule problem. We have tan of this inside piece. And then this inside piece is also a function. So what I'm saying to you is this. What I'm pretending is this. I'm pretending just for a second that this inside piece is just u. So I'm pretending I'm taking the derivative of tan of u. Well, the first derivative of tan of u would just be, let me pull this out a little bit, secant squared u. But of course u is this inside piece, and inside piece is x plus y. Then I have to multiply by the derivative of the inside. So now I have to differentiate x plus y. Well, the first derivative of x is 1. The first derivative of y is y prime. Your professor may or may not call it dy dx. It doesn't matter. They're the same thing. So I'm just going to put that here. 1 plus y prime. If this is bothering you, then what's happening probably is that you have not remembered the chain rule. So here's the chain rule right here for you guys to look at, is the chain rule. So that's what I just applied. Now, remember, our goal here is to find dy dx, otherwise known as y prime. So that's what I want. So the first thing I'm going to do is divide both sides by secant squared of x plus y, which gives us 1 plus y prime is equal to this 1 right here, 1, over this thing I'm dividing by, secant squared of x plus y. I'm going to do just a little bit more math here. I'm going to subtract 1 from both sides, and I'm going to say, okay, my derivative, my dy dx. dy dx is the same as y prime is equal to 1 minus secant squared x plus y minus 1. This minus 1 came because I subtracted 1 from both sides to get rid of this, right? Now, if the multiple choice question was just to find the derivative, then frankly there's more work to do, and it's kind of a pain. It does simplify all the way out, and it simplifies all the way out. And if you ever want to see this, please let me know. I'll show it to you. It's just a pain that y prime is equal to, what did I get, x squared over x squared plus, which is absolutely fine. This would be the completed answer for multiple choice. But if they're asking you to evaluate, at a point, I can do that from here. So remember that when they gave us the x point, they gave us the point 0, 0, right? So I'm going to evaluate at 0, 0. 0, 0. Y is 0, y is 0. 0 plus 0 is 0. Now, keep in mind, this is true. If you can't see this secant squared of 0, don't worry about it. It is the same as 1 over cosine of 0. Remember, it was secant squared. Well, 1 over cosine is secant. Remember, it was squared, so there's it squared. Look at the unit circle in your head for a second. So here's our unit circle. They want at 0. Well, 0 is here. And cosine of 0 happens to be 1, doesn't it? So cosine of 0 is 1. Therefore, I'm going to replace cosine of 0 with 1. I'm going to square 1. 1 squared is still 1. 1 over 1 is 1. 1 minus 1 is 0. So we can say that the derivative of this function evaluated at the point 0, 0 is equal to 0, check mark. Okay? Look, I hope this is helpful. If you're not great at this yet, what you have to do is just keep doing those problems. And if you have specific problems that you want to talk about, if you can send them as a comment to me, or get them to me, however you want to get them to me, I'll gladly look at them with you. You can definitely do this. This is one of those things, though, if you let this go, if you don't follow up on this, you're not going to do well. So try to hang in there. If you have any comments, please make them. And if you haven't already subscribed, please subscribe. Thanks.